Okay, let's dive right into this explainer. Right now, there is this massive, vital shift happening in AI. We're moving away from building those simple turn-by-turn chatbots, and we're stepping into the really complex world of deploying autonomous enterprise agents. But as we make this leap, the engineering challenges, and honestly the cost of getting it wrong, are completely changing.
Think about it. When you drop a long-running agent into a production environment, it has to pull up information, use tools, make multi-step decisions. And when these agents fail, you might assume it's because of a weak model or a poorly written prompt. Nope. As Dr. Nabanita Sinha points out in her research, they are context failures. The model literally just gets lost because the context around it becomes incomplete, stale, or completely overloaded.
And this brilliantly illustrates the big paradigm shift we have to make. Prompt engineering is basically just writing instructions, right? But enterprise AI? That requires context engineering. It's about actively managing an agent's dynamic working memory. You are deciding exactly what information gets into the model's limited attention space, what gets to stay there, and what gets ruthlessly kicked out as it works.
Because if you don't manage that memory, you hit a brick wall. We call it context rot. Look, there's this huge misconception that just throwing more data at a model automatically makes it smarter. Actually, it's a lot like trying to find your keys in a stadium during a rock concert. The signal gets totally drowned out by the noise. A giant context window stuffed with low-value information actively degrades the agent's reasoning. Remember, context is a strictly finite resource.
So, how do we fix this mess? Well, we need a highly structured approach to keep that context clean and high signal. We're going to fast-track through the 7 core context engineering techniques you absolutely need to build reliable enterprise AI. Let's get right into the technical cure.
All right. Technique 1, System Prompt Design. Now, forget those basic act-like-a-pirate personas. In the enterprise, system prompts are strict control layers. By splitting your instructions into rigid blocks, like constraints, rules, and escalation paths, you are building a stable operational framework that sits safely above all that noisy, dynamic data.
Now, what's really interesting about this next one, Technique 2, is context compression, or more specifically, compaction. See, during long tasks, agents build up these massive histories that cause total token overload. Compaction fixes this. The agent basically summarizes its current state and reinitializes its working memory with just that dense, compressed summary, leaving all the raw, messy history behind.
Which brings us to Technique 3, Dynamic Context Retrieval. So instead of front-loading massive datasets like a traditional RAG system, modern agents act a lot more like detectives. They spot lightweight references like file paths or APIs, and they do progressive discovery. They dynamically grab just-in-time information exactly when they need it, which drastically cuts down on context pollution.
Let's move to Technique 4 and see how this builds up, semantic caching. Enterprise workflows have tons of repeated tasks. Now, traditional caching needs an exact string match to reuse an answer. But semantic caching, it uses vector similarity to operate at the meaning level. It reuses outputs for conceptually similar requests. That slashes your latency and your token costs, all while keeping things incredibly consistent.
Next up, Technique 5, Layered Memory Architectures. You absolutely have to separate the active state, that's your short-term memory, from the persistent organizational knowledge in your long-term memory. If you don't have aggressive eviction rules telling the system what short-term data to toss out, your agents are going to hoard stale information and rot their own context from the inside out.
All right, Technique 6 utilizes sub-agent architectures. Think of a single monolithic agent trying to do everything as a digital hoarder. It grabs way too much context and just becomes completely unstable. The fix here is context isolation. You deploy specialized sub-agents to crunch huge data sets on their own, and they only return these ultra-condensed high-signal summaries back to your main coordinator agent.
And finally, honestly, none of this works without Technique 7, Context Observability. Production failures almost always come from these crazy, complex interactions between memory layers and retrieval systems, not just one isolated bad prompt. So you have to track exactly what info was injected and how that memory changed at every single step of execution.
So, the crucial point is, well, it's pretty simple to bring it all together for our executive recap. Across all these 7 techniques, Dr. Sinha's golden rule is this: you must provide the smallest possible set of high-signal information required for reliable reasoning. When it comes to an agent's working memory, quality absolutely trumps quantity every single time.
Which leaves us with a really critical question to consider as we wrap up this explainer. Does your enterprise AI rely on raw model intelligence or actual context management? As these models get smarter, it is so easy to just get lazy and expect them to figure it all out. But true scalable reliability, that depends entirely on how effectively that context is designed, managed, and maintained. Really think about that for your own architecture. Thanks for joining me.